Hello boys and girls, and welcome to lesson 1-4, properties of numbers, on textbook pages 22 and 23. What I'd like to do is take a look at 22 together. We'll answer a couple of the questions together and then jump right to page 23, and I'll do the same. So I'm only going to give a few of the answers just to guide you on pages 22 and 23. Okay, let's start. State whether each conjecture is true. If not, give a counterexample. Okay, so we're going to see if each one of these statements is true or not, and we're going to give an example. The sum of two odd numbers is always odd. The sum of two odd numbers is always odd. No, this cannot be true. This cannot be true. For example, the number 3 plus 5, these are both odds. Odd number plus an odd number equals an even number. So no, this is not true. Now boys and girls, looking at all of these sentences, I am reminded of the SAT test, the test that graduates take in grade 12 to apply to a university. These are actually in the SAT test. I just did one with one of my classes, and these were some of the questions on there. So this is great information to know. Make sure that you know that the sum of two odd numbers does not always equal an odd number. Okay? Just because they're both odd and you're adding them, it doesn't mean it's going to be odd. Continuing. The product of odd numbers is always even. The product of odd numbers. So if I multiply 3 times 5, which are odd numbers, is the product going to be even? Well, no. 3 times 5 is 15. So again, no. And let's see number 3. The division of whole numbers is commutative. Commutative means, boys and girls, that it's the same. Like, for example, here's an example of commutative. We have 15 plus 17 is the same as 17 plus 15. But when we divide, is it commutative? Will it be the same? Well, let's see. Is 12 divided by 6 the same as 6 divided by 12? So is 12 divided by 6? That would be 2. But is 6 divided by 12 2? No, this is a half. So clearly this is not commutative, and therefore it is not equal. Okay, that's the not equal sign. A equal sign with a line through it. So we say no. Okay, and the last one. Here's another statement. All multiples of 3's are odd numbers. So when you're counting by 3's, are all the numbers going to be odd? Well, let's see. 3, 6. Well, 6 is not an odd number. 9, 12. 12 is not an odd number. So it seems like every other number is an even number. So 3, 6 is even, 9, 12, 15, 18, 21, 24, and etc. So no, not all multiples of 3 are odd numbers. That is also a no. Okay, for questions 18 to 25, we're going to name the properties shown by each statement. So we're going to name them. Remember that we have identity of addition and multiplication. Okay, as you see right there, identity of addition and then identity of multiplication. We have commutative of addition and commutative of multiplication. And we have associative of addition and associative of multiplication. We also have one other one that we haven't discussed in class because it really hasn't come up yet. But it's called multiplicative. Multiplicative of 0, or you can have multiplicative of 1. It's similar to identity. Okay, the only difference is, and we have one example of it right here, multiplicative of 0. And that just means that we have a number and another number, but the 0 trumps these other two numbers. Because if I multiply 14 times 0, I'm going to have 0. And if I multiply that 0 times 3, I'm also going to end up with 0. So because we have one 0 value here, it's going to trump the other two numbers. If we didn't have that, we would just have 14 times 3. But ultimately, because we're being multiplied both of these numbers by a 0, we have a 0. And that one's called multiplicative of 0. And there you have it. That is one new one. Make sure that you add this as a key answer, please. Okay, I'll put a little star right there. But I know that if I see that you wrote multiplicative of 0, that you watch this video as well. Now let's just go through these quickly just to discuss them, and you can add your answer yourself. Now, as you can see right here, we are adding, okay, a 0 to a number, and it doesn't really change the number. It keeps the value of the number, so you know that this is an identity. Okay, over here we're multiplying 8 times 1, and it doesn't change the number, so this is an identity as well, an identity of multiplication. Okay, and identity of 1, but it's identity multiplication, right? Over here we're adding, and it doesn't change. The order changes, but the value is still the same. When that happens, we know it's commutative. Okay, down at the bottom over here, we're also adding, and it doesn't matter the order. We have 7 plus x plus 11, x plus 7 plus 11. It doesn't matter. It's also commutative. Okay, as you can see over here, boys and girls, 25, even though we have a variable, it's very similar to 19. Okay, we're still multiplying, and we're multiplying times 1, and it doesn't change what we're multiplying. So as you know, that's identity of multiplication. And then over here we are grouping. We group 9 plus 2, and over here we're grouping 4 plus 9. Over here we're grouping 2 times 8, and over here 8 times 5. When we group the order, it doesn't change the value, so you know that it's associative of addition and associative of multiplication. Okay, so go ahead and fill those out. Let's go to simplifying expressions. Okay, here I've given you 3 answers so that you can work with them and figure out the rest of them. As you can see in 29, we have r, in parentheses, r plus 32 plus 24. Well, the only thing I can work with is the 32 plus 24, and then keep the r. So I have r plus 56. Okay, because 32 plus 24 is 56. And then over here I have 15b times 5. Well, I can't do anything about the b, but I can definitely multiply the 15 times the 5, which gives me 75, and I have b, so now it's 75b. Over here, I have 4 times 2, which is 8, and I keep the x, because the 4 is being multiplied, and the 2 is being multiplied, so we just multiply these two, and then keep the x, and the x can be replaced with any variable later on, with any number. Okay, so use these 3 examples to solve the rest. Let's continue on. Okay, number 38. Use the table to write an expression that shows how many total baskets the Cavaliers made during the season. Simplify the expression. So here we have a basketball team called the Cavaliers. They have free throws. Free throws are just 2-point, or free throws are from the line every time they get a foul. They scored 1,484 points. Okay? We don't know how many 2-point field goals they got. 2-point shots, regular point, because that's represented by F. And 3-point shots, they got 497. So what do we have? We have this many points plus this many points plus this many points. So how will we write that? Okay, add 1,484 plus 494 plus F. As you see right there. So I added these two values plus F. So I was able to find the sum of these two right there plus F. Okay, 39. Okay, for 39, I don't have a lot of room to write my explanation, so please listen and copy. Listen and copy. Let's look at the question. Moreno likes to do her social study homework before she does her math homework. Is doing social studies homework and math homework commutative? Explain. Well, let's see. Let's think. Is there any different if she does her math homework before her social studies homework, or if she does her social studies homework before her math homework? There is no difference, right? It's like saying 2 plus 3 or 3 plus 2. At the end of it all has to get done. So I'm going to say yes to answer the question. Yes, it is commutative. Yes, the order in which she does her homework doesn't matter as long as it all gets done. Please write that sentence down. You can listen to it, rewind, and listen to it again. And write it between 2 stars, or after you write it, write 2 stars. That is a key answer. Question 39. Ming said, 12, 20, and 36 are all divisible by 2 and by 4. So any whole number that is divisible by 2 is also divisible by 4. Well, do you agree? If yes, explain your reasoning. If not, counterexample. Give me an opposite. Well, let's see, boys and girls. 12, 20, and 36 are all divisible by 2 and by 4. But that doesn't mean that all numbers that are divisible by 2 are divisible by 4. Think about the number 14, for example. 14 is divisible by 2, but 14 will not be divided by 4. So, again, I want you to copy this down. Alright, let's put a little star right there and see if you can write it right in there. Okay, write your sentence in there. And this is the sentence I would like you to write. No. 14 is an example that is divisible by 2 and not by 4. Question 41. A ceramics class needs to buy blocks of clay for an activity. Use the table at the right to write an expression that represents the total cost of clay in dollars for the activity. Simplify the expression. Okay, we know that we have the number of students are 19, so we know we have to buy at least 19, okay, minimum, but we don't know how many we need per student. That's B. We don't know if they're going to each need 2 or they're each going to need 3, and we know that the price per block is $6. So we have to spend at least, for each student needs 1. At least each student needs 1. We can assume that. And if each student needs 1, it means we need to spend at least $6 for each one of these. So we have to actually multiply 19 times 6. 19 times 6 is 114. Right? But we don't know how many blocks each one needs, each child needs. They could each need 2. So we just put B. So it's 114 B, 114 times B. And that is the simplified expression. Okay, the following are algebraic expressions, but written in words. So let's see. These are not easy, boys and girls, and I don't expect you to be able to be a master at these right away, and that's why I want to help you. But I'm going to help you with maybe just 2 of them. I'll give you my answers. And then I would like to explore these, revisit these carefully in class. So I'm purposely not going to do all of them so that we actually spend some time on them in class. I will do 2 of them, and I want you to try the rest. Please try. This counts for your effort. And I must see something. You cannot tell me I didn't understand. I must see that you tried and that it's a educated guess or an educative attempt. Okay, let's just try, for example, let's try number 1. The product. Okay, so I know I'm multiplying of 7. So I have 7 and I'm multiplying because product is 7. I mean, product is multiplication. The product of 7 and 4. Okay, 7 and 4. I'm going to multiply 7 times 4 times a number. Oh, now we have a number that we don't know about. And that is also multiplied by 3. So if I read and I just write it as I see it, 7 and 4 times a number multiplied by 3, I'm going to have 7 times 4 and a number, 4 and a number, which I don't know anything about, and I'm just going to represent it with the number, by 3. Times by is the same thing as times 3. And there you have it. Okay? There, that is what you would write, and my answer would actually be 84n. Right? If I actually multiply those 3 numbers and I leave the n where it goes. Let's see, let me jump ahead maybe to 46. Okay, question 46. The difference of 12, whenever we say the difference, boys and girls, we're talking about subtraction. You know this already. The difference of 12 times a number. Oh, 12 times a number. Just like we did 4 times a number up here, I'm going to do 12 times the number down here. So I'm looking for 12 times the number. Okay? The difference between 12 times the number and, but we're looking for the difference, so it's not and, it's not adding, it's the difference. 9 times the number. 9 times the number. It's not another number, it's the number that we previously mentioned. So it's going to be the same variable. 9 and the same number. So my answer here would be 3n. Correct? Okay, try 43 up to 47.